Hello there, Mr. Chan here for Algebra 2. We're going to be doing a topic 4 review. Grab your review packets handed out before. Turn to page 233. This is also available in your textbook if you're curious about that. This is not in your note taker. It is a separate packet. Let's get started on topic 4. Topic 4 is mainly about rational expressions and rational equations. All right, we have some vocabulary to start off with here. Good luck, everybody. Choose the correct term to complete each sentence. Number 2, the blank can be represented by the equation y equals 1 over x. The answer is reciprocal function. Write that in. Reciprocal function. Let me zoom in a little bit more. There we go, much better. Yes. Number 3, a blank is any function r of x equals to p of x over q of x, where p and q are polynomials and q of x cannot equal to 0. This is, of course, the definition of a rational function. Number 4, blank can be modeled by the equation y equals k divided by x. Notice the relationship between x and y are not directly related. They are inversely related. So this is called inverse variation. Number 5, a or n blank is the quotient of two polynomials. Quotient, of course, means to divide. We are referring to a rational expression. Not equation, expression. Number 6, a blank is a line that a graph approaches but may not touch. That is, of course, an asymptote. Number 7, a blank is a fraction that has one or more fractions in the numerator and or the denominator. That is called a compound fraction. Think of it as like a very complicated BLT sandwich. Otherwise known as a club sandwich, right? With 3-4 layers of bread. Number 5, a blank is a value that is a solution to an equation that is derived from an original equation but does not satisfy the original equation. That's the key here. When we're dealing with fractions, we can't divide by 0, and these values that we get as answers make the denominator or divide by 0 impossible. That's not allowed when it comes to fractions. This is called an extraneous solution. A lot of vocabularies. Yay. I think we're ready to get started with the first section. Any questions? Great. 4-1, inverse variation and the reciprocal function. We have some vocabulary here. We have the actual equation, y equals k over x for inverse variation. We talked about how direct variation was also included in some of the homework. That's fine. K, of course, is the constant of variation. And of course, the name of that parent graph 1 over x is called the reciprocal function. And they give us a nice example right here. And keep in mind, this is something typical that will show up on an SAT, ACT. And you want to not try to solve for the problem first. You want to find k first. That's your goal. Find the constant of variation before you actually solve the question itself in this particular problem, okay? All right. I think that example is self-explanatory. I'm actually going to do number 9 and 10 here for you off to the right. Number 9, in an inverse variation, awesome. I'll set that up. x equals 2 when y equals -4. Stop. Take that information and plug it into the equation and solve for k. K divided by 2 equals -4. Move the 2 to the other side by multiplying by 2. Oh, cool. K equals, of course, -8. My constant of variation is -8. Now solve for the actual question. So I'm resetting the equation. We no longer need x equals 2 or y equals -4. We just found k equals -8. I'm setting it up for the actual problem. Here's the answer question. Hey, find y when x equals 16. Put 16 in there, plug it in. -8 divided by 16, of course, is -1/2. And that's your answer. Yay. Not too bad. That's y. All right. Number 10 is pretty much the same process. In an inverse variation, blah, blah, blah. Maybe you can pause the video and try this on your own right now. Actually, maybe I'll just do it quietly. And when you're done, you can check your answer. Look up on my video. So hopefully you guys got y equals 1/2 all over x. Okay. Technically, that's 1 over 2x, by the way. But they didn't ask for the inverse variation equation. I'll just leave that on. Plug in the 2. I know. Divide by 2. You need to multiply by the reciprocal, right? It's 1/2. And my answer is 1/4. Yay. Okay. Any questions about 9 and 10? A little bit of some fraction play there. Just be careful there. Number 11, I'm going to skip. Oh, actually, no, I'm sorry. I'm going to go ahead and graph number 11. Let's do that. Looks kind of familiar. Something we may have done in our note taker. Graph the function y equals 5 over x. And if you compare it to the parent function 1 over x, that 5 is definitely the vertical stretch a value. It's stretching by 5. Now think about it. If I just pick an x value, say 1, we know 0 doesn't work. 5 divided by 0 is impossible. That creates a vertical asymptote. And you notice that there are no h's and k's, so therefore this particular parabola's asymptotes do not shift anywhere, up, down, left, or right. So I know this particular child graph, y equals 5 over x, stays like this, but the branches do get stretched vertically by a factor of 5. When you plug in 1 into this equation, you'll get 5 over 1, which is just 5. When I plot it, I'll get 1, 5. 1, 5 is about right here. And there it is. So there's one of my branches. Whoa. Whoop, not too good there. It's a stretched hyperbola, basically. And if you plug in -1 into the table, you'll get -5. Make sense? And it'll be down here. There it is. Not too bad. They asked for the domain and range. Let's oblige them. The domain is all real numbers except the vertical asymptote at 0. So x won't equal 0 for the domain. For the range, it's the y values except y cannot equal to 0 because there's a horizontal asymptote that exists right there. Speaking of asymptotes, let's list those as well. There it is, vertical asymptote, VA, and horizontal asymptote, HA. And there they are, along with the graph itself. Yay! I am going to skip number 12. I'm actually going to do number 13, a word problem. Crazy, Mr. Chan. Now, the reason why I'm doing this is because you will see problems like this on a SAT, ACT, and on the final. And don't let the words throw you off. Read along with me as I read out loud. The volume V of a gas varies inversely with pressure P. Now you're used to X's and Y's and K's. I'm going to use V's and P's instead of X's and Y's. So V equals varies inversely, put the P in the denominator. I'm going to throw in a generic K, and this is just like the problems in number 9 and number 10, but just in a word problem. They tell you information. They tell you if the volume is 6 centimeters cubed, the 6 is the important part, of course. Put that right there for the volume. The pressure is 25 kilograms per centimeter squared, something you learn from chemistry. So I'm basically doing the same thing like number 9 and number 10. I'm just here to solve for K, my constant of variation. Let's multiply both sides by 25. I'll get K equals 150. Hey, sounds typical of a real world problem. Now I set up my problem now, resetting the V and P values. V equals 150 divided by P. Now I just have to solve for volume. Because the question is, what is the volume of a gas with pressure 15 kilograms per centimeter squared? That is the number I need to plug in. Right there. Okay, not too bad. It really isn't. 150 divided by 15 is just 10. And anytime you work a real world problem, you want to include the actual units. Volume is 3-dimensional. There's my centimeters cubed. That's how much volume that particular gas takes up, and that's your answer. Any questions? Great. Let's move on to the next section, 4-2. All right, here we go. We're going to be doing some graphing. We're going to be graphing some hyperbolas and extended hyperbolas. They start looking kind of weird. Might have to pause the video and break out some graphing calculator, decimals kind of a thing to show you the actual answer. Let's take a look at the review here. A couple of major things they look for. Vertical asymptotes help graph the hyperbola with its branches, as well as horizontal asymptotes. We talked about horizontal asymptotes briefly. Here are the scenarios. When it comes to horizontal, you want to look at the degree. If the degrees of the top polynomial compared to the bottom polynomial is less than, that means my equation is y equals 0 automatically. If the degrees are equal, then you want to look at the leading coefficients of each of the polynomials, that is y equals a over c. And then finally, the other scenario is what happens if the top polynomial's degree is bigger than the bottom? Then you basically say there's no horizontal asymptote. Okay? In fact, I've mentioned this in the lecture before. We do produce something called a slant asymptote, and that's something we discuss in trigonometry. Let's take a look at the example they gave us off to the side here. We have this function, which is a rational expression. And I always like to parenthesize my polynomial so I don't get tempted to start doing crazy things like, oh, let's cancel the x squares. Oh, let's reduce the 25 and 5. That's illegal. You cannot do those two things right there. Okay, those are polynomials. It's all or nothing. So they went ahead and took the denominator and found the vertical asymptotes by setting it equal to 0, as they show you right here. And when they solved it, they got two answers, x equals -1 and x equals 6. So on the graph itself, we do have a vertical asymptote here at -1, and it's kind of hard to see with the picture, and another vertical asymptote at +6. That helps guide the graph. Then finally, they went ahead and looked at the leading coefficients of the terms, and they see for the horizontal asymptote right there, boom, the powers are equal, okay? If they're equal, they went ahead and found the ratio. The ratio is 9/1. Those are the leading coefficients. That equals 9. 9 is right here, the horizontal asymptote, okay? And then, how the heck did they get their branches? Well, you can use a T-chart, and you can plug numbers in. They picked numbers to the left of the first vertical asymptote, plugged it in, and plotted it from there. They picked a couple of points between -1 and 6 to see how that goes. That gives you that middle weird branch. And then I finally picked something like a +7, plugged it into the equation. It's a lot of work, definitely. But your graphing calculator, Desmos, or your actual calculation will show something above the horizontal asymptote. Okay, so maybe this is a good time to pause. And so I just pulled up Desmos. I graphed it on here. I actually included two vertical asymptotes, x equals -1, the blue line, as well as x equals 6, the green line, to show you how this is graphed relative to that. You know what? I might as well put in another equation. Y equals my horizontal asymptote at 9. Let's see what happens. Oh, there it is. Woohoo! That works. Very cool. So relatively speaking, we have our vertical asymptotes, our horizontal asymptotes, as well as our branches that act accordingly. How does that look? Pretty cool, huh? All right. Let's move back to our notes here and actually do some problems right here. There's not really a lot of room, so I need some space here for numbers 14 through 21. Find some space. You might need to get a piece of scratch paper here. All right, very good. Okay, number 14. We're going to go through the whole thing of identifying vertical asymptotes, horizontal asymptotes. We're not going to graph it until we get to number 18, but number 14, let's do it off to the side here, up at the top. Your skills from Algebra 1 are important when it comes to factoring some of these difference of squares, quadratics. It's very important, right? I'm actually kind of, it's kind of habit. I'm kind of parenthesizing all the polynomials so I don't get tempted to cancel any powers or numbers down for me. So 14, vertical asymptotes are first. Vertical asymptotes, we want to look at the denominator. X squared plus 9x plus 14, set it equal to 0. This is where you cannot divide by 0. This is factorable. What times what equals 14? When added together will give me 9. We have 1 times 14 and 2 times 7. There it is. Woohoo! Very good. Split them up and solve. Bam. X equals -2. X equals -7. And those are my vertical asymptotes, okay? Horizontal asymptotes are next. Look at the leading coefficients and the powers. Oh, I don't have to worry about the degrees. If you look at the actual problem, are less than each other, right? X to the first right there. Yeah, see that, the degree right there? And x squared. 1 is less than 2, therefore, automatically y equals 0 is my horizontal asymptote. Woohoo! So number 14 is done. Number 15. Any questions on 14? Okay. I'm going to scooch on over to the right here for number 15 and go through the same process. A lot of factoring going on here, right? All right. Vertical asymptote looks at the denominator. Set it equal to 0, factor that. I have a -6. Oh no, one of my factors is negative, one of them is positive. What times what equals -6 when added together will give me +5. I know it's 6 and 1 because they are linked together by 5. I do need a +5, which means I need a bigger factor. So I'm going to make the 6 positive and that negative. Split them up and solve. X equals -6 for one of my vertical asymptotes, and x equals +1 for my other vertical asymptote. Nice. Horizontal asymptote. Let's look at the degree. The degree of the top in number 15 is 1. The degree of the bottom polynomial is 2. We have the same scenario as number 14. The degrees are less than each other, which means automatically y equals 0. Yay! Not too bad, huh? Practice makes perfect. Let's move on to number 16. Let's do that. Okay, just in case. Yeah, I worry about those types of problems. 2x squared plus 25. Let's set that equal to 0 for my vertical asymptote. Now, this is going to be kind of weird. 2x squared plus 25 can't be factored. It's not a difference of perfect squared. I can't take out a 2. If I move 25 to the other side by subtracting, ultimately, I will divide by 2 and try to square root into a negative number. That's a big red flag. You cannot square root a negative number without getting into imaginary numbers. And we're not graphing imaginary numbers. Here, guess what, ladies and gentlemen? There are no vertical asymptotes. None. None. Okay. So let's look at horizontals. Look at the powers. Oh, the degree of the top is the same as the degree of the bottom, 2 and 2. So the degrees are equal. If they're equal, what you want to do is you look at the leading coefficients of the top one, and that's 1 right there in front of x squared, and divide by that by the 2 on the bottom. So there it is. Y equals 1/2. Okay, that's my horizontal. Moving on to number 17. Same process. Let's go ahead and look at the vertical asymptote for number 17. Denominator, x squared minus 6x minus 16 equals 0. Factor that. Let's see. 1, 16, 2, 8, 4, 4. Oh, 2, 8, -8, +2. Solve that. You gotta be quick, right? This is no time to pick your nose. Gotta practice this factoring business. There are my 2 vertical asymptotes. Sorry, OCD. All right. And horizontal asymptote. Let's look at the powers. The powers are equal. There will be a horizontal asymptote because the degrees are equal. And that is y equals the top, 16, over the bottom leading coefficient, 1. So it's just y equals 16. Okay? Not too bad, right? Not too bad at all. All right. Number 18 through 21 involves graphing. I may not have a lot of room here, but we're going to do the best we can for, and that's all we're doing. We're not doing 22. I'm going to zoom out a little bit and try to find some space here for number 18. Let's set that up. The process is exactly the same as 14 through 17. We're just now going to graph it. Okay, here we go. Yay, difference of squares. I can factor that pretty easily. Solve that. X equals 1, x equals -1. Great. Horizontal asymptote. Ooh, the degrees are less than. If you compare the powers of the top function, x, and the bottom function, x squared minus 1. I meant polynomials, so it's less than, so automatically y equals 0. So back in the day, this is what we did, just a FYI here. And I wonder how much room I have right there. Yeah, I got to be careful. I'm running out of room here. Very careful. Oh, let's go off to the side right here. Nice. So let me draw my vertical asymptotes. +1, -1, and 0. Okay. You may use your graphing calculator. You may use a t-chart, or in my case, I'm going to go ahead and use Desmos. Here we go. Turn those off that I just got. Put in my equation. Sorry about that. Clicking in my keyboard here. Let's do it. X divided by x squared minus 1. Divided by x squared minus 1. Hey, let me zoom in a little bit. Very cool. We have two branches. One's on the lower left, and one's on the upper right, and one's doing that little cool thing for number 18. Let's go back to our notes and just copy it onto there, okay? All right. Woo, and woo. I mean, this is not exactly perfect, but it's close enough for teachers. The main thing is to identify the branches, relatively speaking, and to try to get the asymptotes correct. Number 19, 3 divided by x minus 2. My vertical asymptote is x minus 2 equals 0. Easy, x equals 2. Great. Horizontal asymptote. The degrees are less than, I mean, look at the numerator. It's 3. There's no x involved. It's technically x to the 0 power. The power is 0, and the bottom one, the power is 1. It's still less than. Make sense? Here the degrees are less than, which means automatically y equals 0 is my horizontal asymptote. So let's draw those in. X equals 2, and my horizontal is y equals 0. And I'm going to use Desmos, or you can use your graphing calculator if you like to see what this looks like. Here we go. Turn that off. Put in a new function, f of x equals, don't you love technology, 3 divided by, make sure you use parentheses for the denominator, x minus 2. Oh, there we go. Very cool. So it looks almost like the parent graph, right? And let's go back to our notes and jot down what we just saw right there. Yay! Our 2 branches, and that's number 19. Not too bad. Let's try number 20. Find our vertical asymptotes. How are we doing out there? Yeah, it's running about 15, 20 minutes per section. Usually that's what happens with these reviews. Ooh, look at number 20's denominator. Look kind of familiar? That's a PST, perfect square trinomial. X equals 1, -1 is my answer for my vertical asymptote. It's actually true for both of them. Ditto there. Horizontal asymptote, the degrees are the same. The top degree is 2, the bottom one is 2, therefore the degrees are equal. Which means y equals the top leading coefficient 2 and the bottom leading coefficient is 1. Right there and right there. So my horizontal asymptote is y equals 2. Let's graph that over here on the left. All right, -1. Whoops, wrong color. And my horizontal is at y equals 2. And let's break out Mr. Desmos and see. And you can use a calculator, it's fine. No big deal. X equals 2. 2x squared plus 7. That looks good. Close parentheses divided by. Oh, I just noticed something. Forgot to put the squared right there. Squared divided by x squared plus 2x plus 1. And oh, this is a fancy, weird one. Look at that, folks. Whoa, notice how this curves very nicely. This one is like a sharper curve. And it's due to the fact that x equals -1 is a double root. And what that does, it actually forces this particular branch to not approach it as fast. It's kind of weird. One of those things I observed as a teacher over time. So it's like that. Okay, everybody? All right, let's go back to our notes here. And let's draw that in. There we go. 21. Let's do it. Vertical asymptotes 4x squared minus 1. Ooh, difference of perfect squares. Interesting. That can be factored. 2x minus 5, 2x plus 5. Solve that individually. X equals to add 5 divided by 2. And over here, subtract 5 divided by 2. I have 2 vertical asymptotes. One's at 2.5 and the other one's at -2.5. My vertical asymptotes are next. I'm sorry, horizontal asymptotes. Misspoke there. The degrees are equal. Yay. Which means my leading coefficients are 3/4. And that's my horizontal asymptote. And let's throw those in here. Ooh, 2.5 one way, 2.5 another way. Sorry if I'm getting a little lazy here. And 3/4 is like not even higher than 1. There you go. I got 6 partitions in my coordinate plane. Let's chop that into Desmos. Turn that one off. Okay. Ooh, 3x squared minus 11x plus minus 4. How are we doing out there? Divided by 4x squared minus 25. Minus 25. Let's see. Oh, wow. It's one of those. Yay. It almost looks like number 18, but in reverse order. Okay, y'all see that? Okay. Let's copy that onto our notes. Dun, 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 dun. Dun, 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 dun. This one has a situation where the middle part crosses through the horizontal asymptote. Vertical asymptotes will never be crossed, but horizontal ones sometimes are crossed. All right? Anybody have any questions? All right. Let's get ready for the next section, 4-3. This might be a good time to take a little break, huh? A little potty break or something like that. All right. In fact, let's, woo. All right, here we go, 4-3. All right, what can we do with rational expressions? 4-3 is on multiplying and dividing them. The best thing to do when it comes to these things is to factor. and see what you can reduce. Look at the example that they gave us. Hey, let's multiply these two rational expressions, and highly recommend you parenthesize all your polynomials so you don't feel like you're going to cancel anything away. So you notice that all they're doing is basically breaking it into factors. X squared plus x minus 2 factors out. X squared plus 3x minus 4 factors out. And after you factor, you can reduce anything in the numerator with anything in the denominator. So that's what they did there, and that's what they did there, leaving with this as an answer right there, okay? That's it. That's what it comes down to. Let's try some ourselves off to the right. Okay, we'll be doing 23, 24, 25, and 26. And old habits don't die with me. I parenthesize all my polynomials. It's one of those things I do. Ooh, look at the second half of this. It's division, right? When it comes to division, you want to multiply by the reciprocal. Remember skip, flip, and multiply? KFC. A lot of ways to remember how to divide by fractions. Before we jump to 25, 26, let's do number 23 and 24 off to the side here. Got some room up here? Yeah, I do. Sweet. Okay. 23. X squared plus x minus 12 can be factored. X squared minus x minus 6 can also be factored. So the ones that can be factored, those quadratics, I'm leaving blank in my work. So what times what equals negative 12 when added together will give me positive 1. That's what I'm thinking about. Negative 12, positive 1. It has to be 4 and 3. It can't be 2 and 6 because they're not related by 1. It can't be 1 and 12, right? So it has to be 4 and 3. One of them has to be negative. One of them has to be positive in order for the product to equal to negative 12. So I need a bigger positive number because I have a positive 1x. So there it is, ladies and gentlemen. Bottom one, x squared minus x minus 6. That's one that we can factor pretty good too. So what times what equals negative 6? When added together will give me negative 1x. That's going to be 3 and 2. This time I need a bigger negative, so I'll put the negative sign right there and a positive sign right there. Very cool. Do things cancel? They do. X plus 4s go away. Woohoo! The whole thing can be canceled. X minus 3s cancel. Oh no! And x plus 2s, everything cancels. Now when you cancel, you are leaving a bunch of 1s everywhere. 1 over 1 is 1. That's your final answer for number 23. I almost wrote an equation sign. This is an expression, okay? It's not an equation. But we also need to state the domain. When it comes to the domain and fractions, you cannot divide by 0. The domain is linked to those vertical asymptotes. You want to look here, here, and here. We have 3 factors in the denominator that are not part of the domain. They cannot be positive 3. If you put a 3 in here, that would be 0, right? So that's not part of the domain. Also, negative 2 would make that 0 right there. And finally, negative 4. So 3, negative 2, and negative 4 will make the denominator 0, and that would be bad. That's your domain, ladies and gentlemen. Okay. 24 is next. Zoom out a little bit. Okay, in the numerator, we have x squared plus 8x. You can take out a monomial GCF there. Denominator, you can take out a monomial GCF and factor it as well. Let me take out the monomial GCF first in a moment. The back half, you can take out a monomial GCF too. All right, so a lot of monomial GCFs in this case. First polynomial, x squared plus 8x. I can take out an x. Awesome. When I do that, I'm left with an x plus 8. Awesome. Second polynomial in the denominator, I can take out an x as well. Let's do that. When I do that, I'm left with an x squared plus 5x minus 24. Third polynomial, I can also take out an x. A lot of x's there. Woo! That leaves me with an x squared plus 2x minus 15. Each of those polynomials sometimes can go further. In fact, two of them can go further. We need to take care of that right now. Okay. X times x plus 8 stay the same, times x. And that bottom is a quadratic, and the top is a quadratic. Okay? Meaning this can be broken down further, and that can be broken down further as well. Let's do it. X squared plus 2x minus 15. What times what equals negative 15 when added together will give me 2. How about 5 and 3? One of them is negative, one of them is positive. It has to be a positive 5 because you have a positive 2, which is bigger, and that's negative 3 right there. Great. Let's go on to the bottom. What times what equals negative 24? When added together will give me 5. 124, 220, 212, 38. Oh, 38 will work. One's positive, one's negative. Ooh, stand back. Look at everything, yeah? What goes away? We have lot go away. Bye-bye. Those x's go away. Oh, x plus 8 goes away. Yay. How about this one? X minus 3's go away. Leaving with a x times x plus 5 as your simplified quotient. We do have a domain we have to worry about by looking at the denominators. Here, here, and here. X cannot equal to 0, 3, and negative 8 because they'll make the denominators 0, and that's illegal. Ladies and gentlemen, that is your domain. All right, how are we doing out there? 2 more to go in this section. Number 25. Running out of a little room, aren't I? Ooh. Let's go over here. X squared minus 36 can be factored. That's a difference of perfect squares. Awesome. X squared minus 3x minus 18 can be factored as well. Nice. Let's do those first before we skip, flip, and multiply the second rational expression. So here we go. X squared minus 36, x 6 minus plus, right? Difference of squares. Yay. The bottom one, we have x. What times what equals negative 18? When added together, will give me negative 3. That is 6 and 3. One of them is negative, one of them is positive. Awesome. Now, I have to flip this upside down because I'm going to multiply by the reciprocal for this problem number 25. So when I flip it, I'm going to do everything upside down. When I factor it over here, I'm going to change it to a multiplication, and I'm going to flip it. Both of those quadratics can be factored. Okay? So I'm going to color code this here. What times what equals negative 24 when added together will give me 2. That's going to go into the denominator now. You all see that? 1 times 24, no. 2 times 12, no. 3 times 8, no. 6 times 4, yes. 6 and 4 are related to 2. One of them is negative, one of them is positive. Bam, bam, there it is. And then finally, I'll do purple. What times what equals 12? When added together will give me positive 7. That is going to be what? 1 times 12, nope. 2 times 6, nope. 3 times 4, yep. Both positive. Okay, so sometimes teachers ask you to find the domain first before you cancel anything. Fine, that's fine by me, not a big deal. So the domain, I'm looking at the denominators here, 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 and here. They are 6, -3, -6, +4. But remember the original problem also had in the denominator x squared plus 7x plus 12. That means I got to look up here as well. Up here, this is -3, which is duplication, and -4. That was originally the denominator. Yeah? Those are my restrictions. Restriction, 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 restriction. I can't have that in the the domain. So I'm going to list all those. X cannot equal to those numbers. 6, -3, -6, 4, and -4. Okay, that's what happens when you deal with division. All right, let's go back to my original problem and cancel the heck out of it. X plus 6 goes away. Woohoo! X plus 3 goes away. X minus 6's go away. And there it is, my simplified rational expression. Ding, 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 ding. X plus 4 divided by X minus 4. Woo! Crazy. Last one on this section, number 26. Ooh, factor the heck out of that top one. Times, I'm going to flip that bottom one, of course. And when I flip it, that 3x plus 9 goes upstairs. I can take out a 3, can I? Let me just do that one really fast. That's a mono GCF right there. Take out a 3. That leaves with an x plus 3. Sweet. And flip the other one down here. Okay? Let's do this. I'll do the first rational expression first. 2x plus 5. 2x squared plus 5x minus 3. Ooh, that's a little tougher. A lot tougher. I'm going to guess and check here because I need to see what I'm doing. You can use a box if you want to. I don't care at this point. And that's going to be positive right there, negative. I'm just guessing and checking. See that? Outer product is positive 6. Inner product is -1. Therefore, I'm going to get a 5x right there. I don't expect everyone to do that so easily. You might have to use a box, AC, or diamond method for that. Next one, x squared minus 4x minus 21. That can be factored. 1 times 21, nope. 3 times 7, yeah. One's positive, one's negative. There it is. 2x squared plus 5x minus 3. That one's a little crazy. That's one that's going to go downstairs. Okay. I got to worry about the A and the C there, don't I? I have 2x, x. Oh, that's kind of weird. I need a 5, don't I? That looks kind of familiar. Oh, wait a second. That's the same as the front half. Oh, those are the same, ladies and gentlemen. They're going to be canceled. Ha, 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 ha. Okay. All right. Glitch. Nope. Delete that part. Give me a second. There it is. Give me a moment. Whoops. Technology. I don't want to get in trouble here. This is going on the internet. I don't want to have anybody confused. Maybe my pen's running out of battery, huh? That's what's going on here. Yeah, it is. All right. 2x squared, it's the same. Same one, -1 plus 3. I like to do the domain first. Let's do that. X cannot equal to -3, cannot equal to 7, cannot equal to, ooh, careful here, 1/2. Yeah, move the 1 over, divide by 2, and over here, -3. And the numerator as well, -3. That's kind of redundant. All right, -3, 7, 1/2 are my domain restrictions. They're not part of the domain. And now I'm ready to cancel the heck out of this. 2x minus 1, woohoo! X plus 3s, X plus 3s again. That leaves me with 3 over x minus 7. Wow. Ready for the next section? Crazy. That takes care of multiplication. The last two involves adding fractions and adding fractions in equations. They are tricky because you need a common denominator. This might be a great time to go take a break or something like that. I'm going to keep trudging on. Might as well keep going. I've gone this far. 4-4. Adding and subtracting is next. We just did multiplication and division. We're adding, subtracting rational expressions. When it comes to this, you want to find the LCD, the least common denominator. There's a nice example here off to the left when it comes to that. They went ahead and found a common denominator in this case. That is x plus 5 times x minus 5. Notice they had to introduce an x minus 5 for the second fraction in order for you to add the two fractions together. Otherwise, you can't add them together. It's kind of like pizza slices. The pizza slices can only be combined together if they're the same size. Okay? All right, let's try some problems. Number 28, 29, 30, and 31. Or maybe not 31. All right, here we go. Number 28. Parenthesizing all the polynomials. 30, holy cow, that's a complex fraction, isn't it? I'm not looking forward to that. But we'll definitely do number 28. Here we go. 2x over x plus 6 plus 3 over x minus 1. Notice my denominators are not the same. To find the LCD, you want to find common factors. I have none so far. And if you don't have any, you carry over the other factors. So my LCD is the leftovers here, the carryovers, x plus 6 and x minus 1. So this is how you approach this problem. You need to make it so that each fraction has the LCD. If you compare the LCD with each of the denominators, they're missing something. So let's patch that in, right? Let's expand this a little bit for number 28. This is an expression now. 2x over x plus 6 times something plus 3 over x minus 1 times something. First fraction, I'm missing an x minus 1. See, that's the LCD there, okay? That's the LCD. I'm missing an x minus 1. Got to multiply top and bottom by x minus 1 to patch the denominator. Second fraction, I'm missing an x plus 6. Okay? You know how fractions work. I mean, I could backtrack, I guess, and make a quick little baby example. Okay, what if I'm trying to add 1/3 plus 1/5? Oh, the LCD is 15. Yeah, that's true. 3 times what equals 15? 5. 5 times what equals 15? 3. So that's what I'm doing right now with this particular problem. I'm just patching the denominators to make it match the least common denominator. Let's finish this. Distribute the 2x right there and distribute the 3 right there. Move that over a little bit. That was pretty cool, slick. In the numerator, I'll get 2x squared minus 2x plus 3x plus 18, all over the LCD. Let's clean that up. 2x squared, let's see, negative 2x plus 3x is 1x. All over the LCD, and we'll write it out now. And ladies and gentlemen, this is your answer. Woohoo! Any questions? 29. Here we go. X over, now this is interesting. I have an x squared minus 4 that can be factored and broken down. It hasn't been yet. X squared minus 4 is the difference of squares. That's simply x minus 2, x plus 2. Yay. Take a look at the denominators. My LCD is staring at me. X minus 2 is the common factor, but the x plus 2 is missing. I got to bring that over. If you compare the LCD to each of the denominators of the two rational expressions that are being subtracted in this case, the second one is missing an x plus 2. I'm going to save some room here and just patch it right here. To save some room, okay? Sweet. I do need to distribute that 5. Be careful though, that is a negative 5 being distributed to the binomial that I just patched. Right there, okay? So the numerator is x, then we have the distribution minus 5x minus 10 over the LCD. Clean up the top there, the numerator, I'll get negative 4x minus 10 over the LCD. I want to make sure that nothing cancels out there. What if I took out a 2? Would that change anything? Can I reduce anything? Let's see. Oops. No, nothing cancels. Sometimes you have to check to see if anything cancels. Yay, there it is for number 29. Woo! We are now at the 1 hour mark. Mr. Chan, you're crazy. All right. I'm only going to do one more. I'm going to skip number 31, to be honest with you. I'm going to do 30, though. Let's do that one. This is a like a club sandwich. Multiple layers. There's all kinds of meats, vegetables, all with cheese everywhere. We have two separate problems. Think of it this way. We have a separate problem in the numerator right there. Divide, have a big division bar right there. I'm going to treat them separately, okay? That's all I'm doing. Let's do the top first, and then I'll do the bottom one second, okay? 2 plus 2 over x. This is the top. Put that over 1. Oh, my LCD is x, right? So to be able to combine those together, I need to multiply top and bottom by x right here and right here in order for those to be combined together. This is now 2x plus 2 all over x, the LCD. The bottom one, let's play with that. Same kind of a deal. Make that into a fraction. Its LCD is also x. So let's make a note of that. LCD for both of them happens to be x. So I got to patch that one up too by multiplying top and bottom by x right there. This gives me on top 2x plus 2. Oh, did I put a plus 2? That was an accident. I meant to write minus 2. Sorry about that. Staring in the wrong spot. All over the LCD x. All right, we are dividing fractions. I'm going to skip, flip, and multiply right now for this problem and see what I get. First fraction stays the same. 2. Oh, can I take out a 2 in the numerator for the monomial GCF right there? Yay, that's x plus 1 over x. And I'm going to multiply here. Boom, flip this guy. I got to flip that whole thing. And I also notice there's a mono GCF as well there. I can take out. When I flip it, the x is on top, and the bottom one is 2 times x minus 1. Woohoo! Very good. So with that in mind, ooh, yeah, the 2's cancel, the x's cancel, and that leaves me with an x plus 1 divided by x minus 1. Came out very nice. Looks pretty. I am not going to do 31. Any questions about these 3 problems? Holy cow. That's crazy. All right. Let's jump to 4-5. The nice thing about 4-5 is we need to get rid of fractions To do that, we need to multiply by the LCD. Very different from 4-4. Please be careful. These are different things now. We're now dealing with equations, not expressions. With equations, you want to get rid of the denominator by multiplying by the LCD. When we do that, it eliminates the denominator. When you multiply by the LCD, you want to multiply the numerator only. Please. This technique is a trick to get rid of the denominators. I'm going to briefly talk about the example they have at the bottom, on the bottom left there. Notice that we have an x minus 2 for one of the denominators, x minus 2 over there, and a 4. Okay, the LCD is 4 times x minus 2. What that does, it eliminates all the denominators. It's kind of hard to see in their work. I'm going to represent that here with 34 through 39. Let's get started. All fractions. Now, the nice thing about number 34 and 35 is that they are prime for something called cross multiplication. These are proportions, 34 and 35. With proportions, they can be solved by doing something called cross multiplication. Makes life easier. Here we go. We need some white space up here. 34. 18 over x plus 4 is one fraction. That equals to 6 over, I'm going to make that into a fraction, 1. Multiply the extremes, set it equal to the product of the means. That's what we mean by cross multiplying. Very cool. 18 times 1 equals to 6 times x plus 4. Distribute the 6 there. We now have 18 equals 6x plus 24. Undo operations, right? Oh, by the way, forgot to mention, I apologize. When we're solving equations, sometimes some of the answers don't work. When they don't work, meaning they don't divide by 0 in the denominator, we get something called an extraneous solution, yeah? You eliminate that. They love that on SATs and ACTs. I promise you. They're going to give you the wrong answer as one of the multiple choice questions. Just to let you know, you might choose the wrong one. You have to mentally check your answers. Back to number 34. They love doing that kind of stuff. All right, so we have 6x equals to, looks like negative 6. Divide through by 6 to both sides. X equals negative 1. Let's do a quick mental check. Negative 1 into the denominator right there will not make a 0. So this is okay. This checks out. Negative 1 is your answer for number 34. Yay. Number 35. I'm going to go ahead and do cross multiplying for that one too. Put that 3 over 1. Cross multiply. You multiply the extremes and set it equal to the product of the means. 9 times 1 equals to 3 times x minus 1. Let me know if I'm going too fast. If you have quick questions, you're welcome to just interrupt me. That's fine. No big deal. If you see a mistake, let me know as well. And make them too. Okay, let's undo operations here. What do we got? Ooh. Looks like I'm going to get a nice number. X equals 3. I'm sorry, divide by 3, x equals 4. Will that be extraneous or is that okay? Let's check. Oh, 4 minus 1 is okay. Yay, 4 is correct. Any questions? Okay. Let's see how much room I got here. I think I got plenty of room. Okay, let's squeeze in 36 next. Negative 4 over 3 plus 2 over x equals 8. I might run out of room. I'm sorry. All right. These are not proportions like number 34 and 35. This one's a regular rational equation. Here, the key is to eliminate the denominators. You want to get rid of the 3 and the x all in one shot using a technique called multiply by the LCD. Let's see what that LCD is, okay? That a is over 1, by the way. Yay. We have a 3 and an x and a 1 for our denominators. Nothing is common. That means my LCD is all 3 of those things. I mean, I don't have to put the 1 there, okay? Multiply every term by 3x. Watch what I'm going to do. Negative 4 over 3 times 3x in the numerator only. Second one, plus 2 over x times the LCD 3x. This is a different technique from the last section 4-4. The last section was finding a common denominator. Here, we're multiplying by the LCD. On the other side, you got to multiply that by 3x as well. The point of multiplying every fraction by 3x, the LCD, is so things can cancel. Notice in the first half, 3's cancel right there. Yay. Second half, x's cancel. The fractions are no longer there. Brilliant, huh? Clean up the rest. Negative 4 times x, 2 times 3, and 8 times 3x. Okay? Add 4x to both sides. We're trying to combine like terms here now. We're going to undo and solve for x. Yeah. We're going to get a fraction here. Boo, hiss. 6 over 28 reduces to 3 over 14, and that is your answer. X equals 3 over 14. Weird answer. I'll take it. Quick check, though. Will 3 over 14 under there make that illegal? No, it's fine. Quick mental check there. 37. It's getting crazy, isn't it? All right. That is not a proportion. It's a rational equation, which I got to solve using the same technique. Bear with me while I write this problem down. Ooh, that 5 is over 1. LCD looks like x plus 3. We're going to multiply by x plus 3. Okay. Whew. After a while, you don't have to write that. You can just, in your mind's eye, mentally cancel the x plus 3s. You can do that. I'm going to write it all out. Okay, this is for notes. First fraction gets multiplied by the x plus 3 in the numerator only. Second fraction, 5 over 1, gets multiplied by the x plus 3. And the third fraction gets multiplied by the x plus 3 as well. And again, you can start seeing ways of canceling this in your head. Very cool. Let's cancel. No more fractions. All right, left side, we have a 2x. Right side, I got to distribute the 5. That gives me a 5x plus 15. And that's plus 6x on the end. Clean it up. Ooh, let's move the combine 5x and 6x together. And undo operations here. Doesn't look good. Looks like it's going to be a negative answer. Oh well, who cares? Let's subtract 11x to both sides. Doesn't bother anybody. 2 minus 11x is negative 9. Divide by negative 9 to both sides. Reduce the heck out of that 5 over negative 9, 15 over negative 9. X equals 2, negative 5/3. Okay? And that is also okay. 5/3, negative 5/3 will not make the denominators there in the original problem illegal. So we don't have any extraneous solutions there. All right, how are we doing out there? Okay, it looks like, it really does look like that. We don't have any, oh, speaking of the devil, let's move the 38 next. Wow. All right. Got a little more to go. -8 plus 64 over x minus 8 equals to x squared over x minus 8. LCD, it looks like x minus 8, right? Multiply by the x minus 8. That's the LCD. -8's first, times x minus 8 in the numerator only. Plus 64 is next, times x minus 8 on the top. So that equal to x squared times x minus 8 in the numerator. Things cancel, don't they? I'm now left with a -8x plus 64 equals to x squared. 64 is 128. Move the -8x and 128 to the other side. Subtract 128 to the other side. And let's see what we'll get here. 0 equals, we're going to get a quadratic here, folks. 128, holy cow, that's crazy. Well, it works. 16 and -8 work. Crazy enough. Split them up and solve. X equals -16 or x equals 8. Here's the thing. These two answers is not your answer. X equals 8 is extraneous. It will make my denominator there 0. This is extraneous. Crazy, huh? The only answer is x equals -16. Woohoo! Got through that one. Number 39, last one. Wow, thanks for hanging in there. Good job. Can't believe I got this far myself. This has to be one of the longest reviews of all time for me. Can't believe it. Ooh, we have a difference of squares in the denominator. That can be factored. X minus 3 times x plus 3. Cool. X minus 3's can be canceled. That's a cool trick right there. And you know what? I have a proportion right now. I'm going to cross multiply. 9 times 6. Set it equal to the means. 3 times x plus 3. That's allowed. Isn't that cool? So I have 54 equals to 3x plus 9. Solve. 3x equals, what is that? 45. Yay, divide by 3 to both sides. X equals 15. Quick check, will that cause any problems there or there? No, that is your answer. Yay. Thank you for hanging in there. Whew, go take a break. I need a break. Hope you guys have a good day. See you later. Bye-bye.